Hi, welcome to this video on negative exponents. First we will try to discover the meaning of a negative exponent, and then we will try to apply that definition to several problems. As you can see, I've written x to the third over x to the fifth twice, so that I can look at what that value is from two different perspectives. On the top example, you can see that I've written what x to the third is by expanding it out, and I've done the same thing for x to the fifth. Now, using our idea that we had learned earlier that we can cancel identical factors on top and bottom, I can say x goes into itself once, x goes into itself once, this x goes into itself once, this x goes into itself once, this x goes into itself once, and this x goes into itself once. The end result is I have nothing but a bunch of ones multiplied by each other on the top. But what I have on the bottom are the two remaining factors of x, which we can write efficiently as x squared. So the reason that I have x squared in the bottom is because there were more x's in the bottom to begin with. So when x's get left in the bottom, it meant that's where the larger amount of x's were to begin with. We have also looked at this from a vantage point of subtracting the exponents when the bases are alike. Both bases are x's, so it's okay to subtract their exponents. Basically, this gives me x to the negative 2. If these are two legitimate ways to look at the same problem, then these two expressions here have to be equivalent. So basically we're saying x to the negative 2 can be written as 1 over x squared. A more formal way of writing this is to say that if I have a quantity to a negative exponent, then it is the same thing as 1 over that same base to the positive version of that exponent. Because remember that the negative exponent comes from subtracting a small exponent minus a larger exponent. It means that the leftover b's would be in the bottom of the fraction. So this is the definition of a negative exponent that we're going to be working from. Let's look at several problems that involve negative exponents. First example would be just a straight version of applying the meaning of a negative exponent. If I have 3 to the negative 2, what it means is the same thing as 1 over 3 to the positive 2. Of course, 3 to the positive 2 is just a 9, so my final answer ends up being 1 over 9. In my next problem, I'm going to have 3 times 4 to the negative 2 power. Now this problem has a lot less to do with negative exponents and has mostly to do with the order of operations. I see both multiplication being shown and powers being shown, and we know we should be doing the powers first. So what this really means is 3 times, and we have to raise a 4 to the negative 2 first. Well, 4 to the negative 2 is the same thing as 1 over 4 squared. And then 3 times, and then 1 over 4 squared is just times 1/16. And our final answer is 3 times 1 over 1 times 16 for 3/16. What you should not do here is go 3 times 4 and then take that 12 and raise it to the negative 2, because there you're breaking the rule for the order of operations. And now that we've defined what a negative exponent means, I may sound like I'm contradicting myself when I say don't be too anxious to apply that definition. You should always look to use the more basic rules of exponents first, before you apply the definition of a negative exponent. Looking at example 3, I have x to some power and x again to some power, and we know in that case we may add the exponents. So this just gives me x to the third. Notice I never had to deal with the whole idea of x to the negative 4 being a negative exponent. Looking at example 4, I see that again the bases are alike, so I'm allowed to subtract the exponents. So I'm going to write x to the 5 minus a minus 2. Be careful. I have to subtract the exponents, and that negative sign down here is belonging to that negative 2. It is not the subtraction operation that I'm using. So I'm going to get x to the 7th. And once again, the whole negative exponent situation did not need to be handled because the basic rules of exponents, the rules that you see out here to the side, these rules that we've used before, were applied first. Finally, with example 5, you can see I have x to the negative 4 to the negative 2, and if you remember right, when you have x to some power then raised to a further power, we're allowed to multiply the exponents. So for this problem right here, I get x to the negative 4 times negative 2, which is x to the positive 8, and once again I'm spared needing to deal with the negative exponent situation because my more basic rules cleaned it up for me. I should mention that after you have applied all the basic rules, if you still have negative exponents, at that point you would rewrite your answer free of negative exponents by applying the definition of what a negative exponent means. For instance, this problem right here, we know that we have a basic rule that says when you have two bases the same and you're multiplying, you may add the exponents. You can see that brings me to x to the negative 3rd power. At that stage, I have applied the basic rules that were available to me, and now I would rewrite my answer as 1 over x to the positive 3, using the idea that b to the negative n is the same thing as 1 over b to the positive n. So we would leave our final answer this way because it's more understandable by others who might look at our work. I hope you found this video helpful, and here are 4 problems for you to try on your own, and please bring the results to class.